Welcome back, viewers. Today I want us to look at a different question on longitude and latitude. In question 16, the position of two terms x and y are given to the nearest degree. X lies 45 degrees north, 10 degrees west, and y 45 degrees north, 70 degrees west. So the questions are: find A, the difference in longitude; B, the distance between the two towns in 1 kilometers; take the radius of the earth as 6370 kilometers; and then 2, the distance between the two towns in nautical miles; take 1 nautical mile to be equivalent to 1.853 kilometers, and then the local time at x when the local time at y is 2 p.m. So to get this question right, let us sketch the relative position of the two towns x and y on the globe. Now, that line, the horizontal line, I'll call it my equator at 0 degrees. That will be my equator due east. I'll draw a vertical line here to represent our Greenwich meridian at 0 degrees, so that any point that lies on the right hand side, we are going to count from 0 due east up to 180 degrees east. Any point that lies to the left of that line, we're going to count from 0 up to 180 degrees due west on the other side. So the pole, this will be the North Pole and this will be the South Pole. So any angle measured due north will increase from 0 up to 90, due south from 0 up to 90. Now hypothetically, where does x lie? X lies, we draw a hypothetical latitude and call this 45 degrees north, due north, and then 10 degrees west. From 0, we draw another hypothetical longitude and call this 10 degrees west. So this is where x lies. That is our town x. Where does y lie? They lie on the same latitude, 45 degrees north but 70 degrees west. So if this is 10, we draw a hypothetical longitude to represent 70 degrees west. So this is our town y, like that. So we have the two towns x and y. In part A, we are told to find the longitude difference. Since they lie on the same side of the meridian, they lie westward, the longitude difference will be given by 70 degrees minus 10 degrees, which is equals to 60 degrees. That part is answered. And then in part B, Roman 1, find the distance in kilometers. The distance in kilometers, both of them lie on a small circle. And if they lie on the small circle, the formula we're going to use here to find the distance in kilometers, we are going to get the longitude difference, which is theta over 360 multiplied by 2 multiplied by pi 22 over 7 multiplied by the radius of the earth. The radius of the earth, which is 6370 according to what we've been given, times the cosine of the latitude, which is cos 45 degrees. So this gives us 60 over 360. When you substitute here, you'll get 60 over 360 times 2. So this is 1 over 6 times 2. This gives you a third, times 22 over 7 times 6370 times cos 45 is 0.7071 from your calculator. Simplify all this, multiply all this using your calculator, and you're going to get this with an approximate value of 4,719 kilometers. That. And then in part 2, in Roman 2, you're told the distance in nautical miles. Take 1 nautical mile. Roman 2, what is the distance in nautical miles? And you're told that 1 nautical mile will be approximately equal to 1.853 kilometers. So how many nautical miles will be there in 4,719 kilometers? So you cross multiply and divide by this, you'll get 4,719 divided by 1.853, which gives you an approximate value of, use your calculator to work out this, 2,547 nautical miles. Like that. Finally, you're told the local time at X when the local time at Y is 2 p.m. Now, time difference. We know that if we look at our diagram, X and Y are 60 degrees apart. And since the Earth rotates in a west-easterly direction, we are told that the time at Y it is 2 p.m. What will be the time at X if the longitude difference between the two is given by 60 degrees? We know that a difference of 1 degree in longitude gives a difference of 4 minutes. 1 degree in longitude difference gives a difference of 4 minutes. So in 60 degrees, we are going to have a difference of 240 minutes. I've just cross multiplied. Convert this into hours. You take 240 divided by 60. This gives you a difference of 4 hours. And we know that the Earth rotates in a west-easterly direction, from west towards east. It rotates in that manner, meaning that any point that is easterly is ahead of time to any point that is due west. So y will be ahead of time and x will be behind time. So if at y it is 2 p.m., at x it will be behind time by 4 hours. So when you convert this into 24 hours, you're going to get this as 1400 hours minus 04 hours, and this gives you 1000 hours. Now in a 12-hour clock system, you can convert this and say the time at x, the time at x will be 10:00 a.m. So that is the required answer. Thank you for watching.